Hello all, welcome to the first episode of AI Safari 2022. My name is Mark Thomas, your AI ecosystem guide and part of the Dell Technologies data analytics and AI organization. Today we're going to talk about graph databases. Now, I don't know about you, when I think of graph, I'm immediately taken back to calculus and graphing. This discussion will have nothing to do with that, at least I don't think so. I hope not. If you're not already familiar with graph databases, they're essentially a relationship-first database, and it's ideally suited for fleshing out those hidden relationships in data, and TigerGraph is a dominant player in the market. Not only is Dell a customer of TigerGraph for several use cases, we're also a partner, and let me tell you, there's tons of buzz internally about our new partnership with TigerGraph, but I digress. There's an interesting relationship between graph and machine learning being a subset of AI. And one of those benefits is it flushes out or provides more value in the data and provides more efficiency for machine learning solutions. This is what we're going to chat about today. And who better to help us understand this topic than Dan Eaton with TigerGraph. Hey, Dan, how's it going?
Hey, Mark, doing great. Thanks for having me.
Absolutely. Before we get started, would you share just a little bit of background on yourself?
Yeah, sure. So I'm Dan Eaton, Director of Business Development at TigerGraph. And prior to joining TigerGraph, I've spent the last decade working in the area of accelerated computing, using hardware to build the world's highest performance, big data, signal processing, and AI solutions.
Awesome. Okay. Sounds like you've been a busy guy and you're even busier today.
Yes, it's very exciting, and I love the intersection of the world's largest computational problems and innovative technologies like graph technologies that we'll talk about today, as well as deep learning.
Awesome. Thanks. Looking forward to that. So as we get started, Dan, just at a high level, can you help us understand what is a graph database and why is it better positioned than, say, traditional relational databases or even NoSQL databases for certain use cases or workloads?
Yeah, certainly. So to start off with, Jensen, the founder and CEO of NVIDIA, I think he said it best in his November 21 GTC keynote. He said, graphs are the native format, the most natural data structure for the world's data. How molecules connect to each other in a protein, how people are connected in the social graph, how roads are connected to towns and to cities, the states, the countries. Using graph, PayPal significantly improved their collusion fraud detection. Amazon used it to improve Amazon search and reduce abuse and fraudulent sellers and buyers. Pinterest scaled search and recommendation to 500 million users. So let's kind of break it down simply, Mark. You and I are both people. Mm-hmm. Our relationship is
my wife calls me an animal sometimes, but that's the side.
Yeah, no, that's definitely an attribute that we'll put in your labeled property graph, that you might have some characteristics that are very animal-like. I think it's a pretty straightforward relationship, but it's something that everyone can understand in terms of representing that relationship in a graph format. You and I are both what are called nodes. So in a node, you have a data point, and the way that those data points are connected, the relationship is represented by an edge. Mm-hmm. So these individual data points, they can have attributes. So just like in a key value database, where you can have a number of attributes that are connected to that data point, you can also add attributes to your edges to give more insight into that relationship. But the most important thing in graph is that you have your data points expressed as nodes, and the relationship between the data represented as edges.
Mhm.
And so graph is a really great way of making sense of our data to understand these connections and relationships in the data.
Got
And
it.
I think you had a second part of that question, which is like, how does graph compare to relational databases or NoSQL databases? And the big comparison is databases have evolved over time. So graph is actually not a new concept. Graph theory is very, very old. And in fact, NASA's Apollo space program had to keep track of parts within different modules and components as in their space program. And so they did so with a rudimentary graph database. How components connect into assemblies and modules, it makes sense. The relationships between those components that form assemblies and modules and how you connect all that stuff, you can do it in a graph much better than if you were to put it into a number of tables and express those in a relational database. So relational databases have a very rigid schema, and to understand the relationships, that fun example of the Mark and Dan graph, we would have separate tables that represent Dan and Mark and our attributes. Mark having certain attributes like an animal, and I probably have a diversity of different attributes, that some of which would be positive, some of them might be negative. And then to be able to figure out the relationship between us, we would have to do a table join there. A single table join is that's not a big deal from a performance standpoint, but if you have to do that across billions of relationships, it becomes very untenable. So that's where graph, you can traverse those relationships very easy. And relational databases, they've been around for a long time. They have really good performance for some simple transactional use cases, but very poor performance for deep connected analytics. NewSQL and NoSQL databases, they don't have a rigid schema. In many cases, they had no schema or a very fluid schema, which gives good performance for simple transactions, like in a key value database or a columnar database. They've been able to support a number of large scale analytical transactional use cases. But again, the data in those databases are not stored in a native graph format, so they perform very poorly for deep connected analytics. And so TigerGraph, which we're a property graph, we have a very flexible schema that enables both high performance for complex transactions, and then that really important for traversing large graphs and understanding those complex relationships. We have very high performance for those deep link analytical use cases.
Got it. Okay. So now we understand, we got some insight into what is a graph database, its distinct advantage, I would say, over some of the more traditional databases like relational or NoSQL. Let's dig in a little bit more. So we understand machine learning is really used to help organizations help make predictions about based on data. So make predictions based on data inputs into a trained model. So how does graph integrate with a machine learning algorithm?
Yeah, it's a really good question. So we talked about the concept of a graph. So this concept of data points being represented as nodes and the relationships between the data points being represented as edges. And so once that data is in that graph format, now you can apply both unsupervised algorithms as well as supervised machine learning. So the cool thing about graph is you can you can get incredible value from unsupervised algorithms that are really great at understanding things in that graph. So in 1997, even Larry Page from Google, he filed a patent for a graph algorithm that was core for Google's search engine. The algorithm is called PageRank. You might have even heard of it.
Yeah, I have.
PageRank outputs a probability distribution that represents how likely a person is clicking on links will arrive at any particular page. So it's used to rank web pages to provide relevant search results. Okay, so these graph PageRank is just one graph algorithm. There's many different graph algorithms, and graph algorithms can do things like find similar patients. The world's largest healthcare company uses TigerGraph to find similar patients, comparing one patient versus 100 million other patients to provide better care and better customer experience. There's other graph algorithms that can do things like pathfinding. So when you go onto a mapping website or application like Apple Maps, and you want to figure out how to drive from one location to another location, finding that path through the roads can be done using a graph algorithm. So these graph algorithms are really valuable and can help understand these relationships to find things like similarity, to find things like pathfinding, communities. And TigerGraph has an in-database data science library. And this library is actually a collection of over 50 algorithms. And these algorithms are represented as G-SQL queries in our platform. So data scientists and machine learning practitioners can run these in database. And it's really great for a number of reasons. They're Turing complete with full support for imperative and procedural programming. They're parallel and distributed processing, so they can work on large distributed graphs. So that's one of the differentiations in TigerGraph, is we're the only massively parallel processing graph database. So we can scale up and we can scale out. They're also user extensible. So because they're written in standard G-SQL, which is our graph SQL-like query language, and compiled by the user can customize them and modify them, and they're open source. So when you look at the implementation, you can actually learn, and data scientists and machine learning practitioners and algo developers they can improve upon it, and they can always update those, customize them, and even commit back to the library. So those are all really, really cool things. In addition to doing unsupervised graph learning, you can also do supervised learning, and the graph can work with graph neural networks also. Mm-hmm. So lots and lots of cool use cases, and we're really excited to see what the community and our customers are doing with graph technologies.
Yeah, it's definitely an exciting technology. There's really remarkable market potential and relevance to customers of all verticals and all sizes. So I know that we're increasing our conversations regarding graph and relevance to customers. So there are a lot of players out there in the graph database market. And you talked about, so you mentioned the MPP, TigerGraph's MPP. Are there any other distinct advantages that TigerGraph has over the other players?
Yeah, definitely. So the graph market's growing very, very fast. We're seeing tremendous adoption from the world's largest and most innovative companies. And Gartner believes that today there's about 10% market adoption of graph technologies for data analytics innovations, and they believe it'll ramp up to 80% in 2025. So how we get to 80% adoption of this technology is really only through kind of the evangelism and education that we're undertaking right now. And how TigerGraph plays in the graph space is TigerGraph was developed by our founders who have really unique backgrounds. So they come from the world's largest technology companies that gave them experience solving some of the world's largest graph problems. So companies like Twitter and Facebook. They also, our founders were composed of database experts, deep database experts who understand how to build massively parallel processing databases for companies like Teradata and Oracle. So what that leads to is we're the latest evolution in graph databases, and our differentiators really there's a few main features. We talked about that MPP being able to scale out as well as scale up, taking advantage of ubiquitously available computing, both in on-premise as well as in the public clouds. And our founders developed our engine in C++, so it's very, very high performance. We also have the ability to really differentiate based on our Turing complete SQL-like query language, GSQL, which data scientists and machine learning practitioners love because it has an easy learning curve, and it enables these user extensible graph algorithm libraries for in-database machine learning. Also some cool features around analytics like accumulators. And so what that leads to is we have a really complete graph database. So it's a native graph database. We have a graph storage engine that's native. We have graph compute in our platform. And then we can perform both transaction processing as well as analytical processing and machine learning all in the same platform. So we've got strong consistency and ACID compliance on the transactional side. We can do the deep link queries going really deep, greater than 10 hops deep very easily. And that's something that really will lead to the democratization of graph analytics and really ramp up that adoption in industry. So I'm really excited about what we're doing with Dell, and yeah, I think that's our key areas of differentiation.
Yeah, and they're relevant and I think impactful. There's also one that I was reading. It's a benchmark that really illustrated the overall performance advantage you guys have. I don't know if you can talk a little bit about that.
Yeah, certainly. So yeah, TigerGraph has done a number of performance benchmarks. One of the top performance benchmarks in the areas of graph, especially relevant for enterprise graph users, is done by the LDBC. It's called LDBC SNB, and TigerGraph shows category leading performance at a scale that no other vendors have been able to complete. So we can show very high performance at greater than 30 terabytes today. So it's great, and benchmarks are fun, but I think what's even more important for enterprise customers is that we can operate and meet their stringent SLAs for enterprise use cases like customer 360, fraud detection, helping on the cybersecurity side, doing supply chain optimization. And so I think, yeah, we've got great benchmarks available, but more important than that is our performance for mission critical, large scale industry use cases.
Yeah, and I would say all of the above are reasons that we are a TigerGraph customer for, like I mentioned earlier, several use cases. So
Yeah, it's really cool to see what Dell's doing in terms of using graph to modernize your customer journey for your many customers. Dell's one of the largest 100 retailers globally. So you guys are really innovating in that domain, and we look forward to helping you improve your customer experience, customer satisfaction, and get that NPS higher.
It sounds great. Thanks for that. I have one more question for you, and it may be the most important question today. Are you ready?
Yes.
Okay. What's a guy who's elbows deep in graph technology do for fun?
Yeah, well, for me, I'd say the two things that I like to do. I like to fish. I'm an avid fisherman, freshwater primarily, and I also enjoy hiking with my wife and 3 kids.
That's awesome. Those are great things. I enjoy those myself. I just learned something new about you, my friend. Well, Dan, it's been fantastic chatting with you. Hope to have you back for more graph talk. And thank you all for tuning in today. And please check back for more episodes of AI Safari coming soon. Thank you. Cheers.
Thanks, Mark.